Hi everyone, I'm sorry for the late video, but this video is due tomorrow by 9 a.m. And today we're going to talk about writing a linear equation without the y-intercept. So the first example is a word problem. So Jason is a babysitter. He charged an initial fee and an hourly rate. The table below represents how much he would charge based on the number of hours. So here's the table. And based on what we did in class today, you're going to be typing this in to L1 and L2 in our calculator. So if you have a graphing calculator, go ahead and do that now. All right, great. So part A says to write the equation to model Jason's earnings from babysitting. So the first step is to go to Stat Edit. So I'm going to open up my calculator. And I need to go to Stat, and then Enter on Edit. And I already have something in L1, and L2 is already blank, which is good. But I need to clear out everything in L1. So let's go scroll up, highlight the L1, and then click Clear, Enter, and then we're all clear. So I'm going to input those values from the table. All the X values go into L1. So that is 3, Enter, 6, Enter, 8, Enter. And then the Y values, which was 51.50, enter, 96.50, enter, and 126.50, enter. Great. The third step is to go to Stat, slide over to Calc on the right, and scroll down to LinReg. Lin stands for linear, so it's going to generate a linear equation for us. And click Enter twice. Enter, Enter. Great, so this tells us the A. The A is 15, and the B is 6.5. So let's go ahead and write that in. So we have A was 15, B was 6.5, and the way the calculator gave it to us was in AX plus B. So this would be our slope, A, and then our B is our y-intercept. So my equation is y equals 15x plus 6.5. That is our equation. Okay, part B says, how much is the initial fee? So another word for initial, what that means is starting. So starting fee normally refers to the y-intercept. And since we're talking about a cost, we can't just say 6.5. What that represents is the starting fee was $6.50. So include the dollar sign. Part C says, how much does Jason charge per hour of babysitting? So this is something that happens again and again. Every single hour he babysits. And what that refers to is the slope. So our slope was 15. So what he charges per hour is $15 per hour for babysitting. If you don't have a calculator, it's really important that you get one. If you need a discounted one, there's some in the main office that you can purchase. Let's scroll down to example 2. This one's slightly different. The following pattern is linear, however figures 1 and 3 are missing. Part A, write the equation to model this pattern. So it already tells us that this pattern is linear, so that means I can use my calculator trick. So before I use my calculator trick, I need to know what table of values I need to put in. So what are my X and what are my Y? So we don't know figure 1 and we don't know figure 3, but we know how many are in figure 2. So in figure 2, which is an X, figure 2, how many boxes are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So figure 2, there's 13 boxes. So that coordinate is 2, 13. Figure 4, let's see, 1, 2, 3, 4, 5, 6. That's 6 in a row, 6, 12, 18, 24, 25. The next coordinate is 4, 25. So that tells me what to put in my table, 213 and 425. So we're going to go back to our calculator. I'm going to clear this. Go to Stat, enter on Edit. And now I need to clear out these columns. Click Clear up on L2. And Clear on L1. Click Enter. So my L1, the only x values I had were 2, enter, and 4, enter. And 2's coordinate was 2, 13, enter. And then it was 4, 25, enter. Then we go to Stat, Calc, scroll down to LinReg, and then hit Enter twice, enter, enter. So what that gives us is A is 6 and B is 1. So our slope is 6 and our y-intercept is 1. So let's go back to our worksheet. Our calculator gave us A is 6 and B is 1. So what that means is the equation is y equals 6x plus 1. That's what the calculator told us. So part B says, how many blocks should be in figure 1? Well, let's think about this a little bit more. 6 here is our slope, which means that our blocks are counting by 6. So if I'm counting by 6, figure 2 to figure 3 plus 6 would get us 19, and then plus 6 more, just to double check, is indeed 25. So if I want to backtrack to figure 1, I need to subtract 6. 13 minus 6 leaves us with 7. Okay, so in figure 1 should have 7 blocks. Okay, another way you can do it is by substituting 1 in for x, and then we can evaluate. So there's 2 ways. I'll show you both ways. So in my equation, I'll write y equals 6, leave open parentheses for the x, plus 1. And in my parentheses, I'm going to replace it with the input 1. That's the figure that I'm trying to figure out. And when I simplify, 6 times 1 is 6, plus 1, 6 plus 1 is indeed 7. So we still get to the same spot here, 7 blocks. Let's scroll down to part C. How many blocks should be in figure 2? That's a mistake because that should have been figure 0, but we already know figure 2 has 13 blocks. We see that clearly in our pattern. Oops. And part D was, what was the starting number of blocks? Whenever we see starting or initial, at this point we should know this means y-intercept. So our y-intercept is the b value right here. So our y-intercept tells us that figure 0 had 1 block. If you have any questions, please write them down below to ask tomorrow in class. Have a good night, everyone. See you tomorrow.